Fingers are an interesting rigging problem, which can vary a lot depending on requirements. For Mr. Hot Dog's fingers, however, we're going to assume that an FK-style rig will be fine, and that the finger digits just need to be able to bend and rotate. But you can imagine that an IK-style rig can be helpful in many circumstances, such as typing on a keyboard. The simplest finger rig you could create would be to just add one bone for each segment of the finger, and put them in a bone chain. This is certainly workable, and animators can indeed animate this way. However, this requires that the animator manage each segment of the finger individually, which can be a lot of work when we're dealing with a whole hand of fingers. So how can we simplify this? Well, remember that when we designed the leg rig, we started by looking at how legs typically move. That's pretty much the starting point for making any simplified rig, observing how things actually move and function. So let's take a look at how fingers typically move. The main thing I want you to notice is that the second and third knuckles usually bend together in a consistent way. They also typically only bend on one axis. By contrast, the first knuckle can bend independently quite easily, and in fact often does. It also frequently bends on two axes. So given that the second two joints move together, and basically only move in one way, that means we can easily assign just one control to both. In fact, if we wanted, it could be a single number, corresponding to the angle of rotation of both joints. However, the first joint needs a more full-fledged rotation control. Still, this simplifies things a lot. Instead of the animator dealing with 3 axes of rotation for 3 bones, they only need to manage 3 axes of rotation on one bone, and then a single additional parameter. How can we design the rig to efficiently exploit this, though? One thing that would be nice is if we can make all of this operate from a single control. Ideally, we don't want the animator to have to switch selections to tweak different parts of the finger. It would be much nicer to just have one control per finger. To accomplish this, I'm going to introduce a new concept. Now, using things like drivers, we can make any parameter drive any other parameter, right? So, for example, we can make the scale of one bone affect the rotation of another bone. This kind of mapping from one kind of transform to a different kind of transform can be really useful, since often not all of the transforms, location, rotation, and scale, are relevant to a control. If the scale of a control isn't being used directly, why not make it do something else? A word of warning, though. You want to use this kind of thing sparingly, because it can easily reduce how intuitive and obvious and friendly your rig is to use. It is not obvious that scaling a control will cause something else to rotate. It's the kind of thing you have to explain to an animator. And the more of these weird exceptions they have to keep in their heads, the more they have to think about the rig, and the harder it is for them to focus on animating. So doing this kind of thing really needs to be worth it, and you shouldn't do it all over the place. So let's try this out. Let's create a 3-bone chain, and let's switch the armature to wire and X-ray and turn axis display on. And let's name our bones. And let's make sure that the bones are aligned in a nice way. I find that it's nice to try to make the primary axis of rotation the same on all controllers. I usually use the x-axis. So, for example, fingers usually bend primarily in one direction, so I want to make that the x-axis. Moreover, let's try to make that direction a positive rotation, rather than a negative rotation. Setting things up this way keeps the controls consistent for the animators when they're working in the animation curves editor. It looks like we're already good as far as rotating on the x-axis goes, but if we bend the finger on the x-axis, the rotation is happening in the negative direction, so let's flip the roll of the bones 180 degrees. We should also probably change the rotation mode of the bones to Euler, because fingers rotate so much on a single axis. Since x is the primary rotation axis, it makes sense for it to be the last axis in the rotation order, so that it stays aligned with the hand, or whatever else we might parent this rig to. And we probably want the twist of the finger, in this case the y-axis, to stay aligned with the local rotation of the finger, so it should probably be the first axis. That leaves the z-axis as the middle axis, which can cause gimbal lock. but since z is the side-to-side motion of the finger, and fingers only rotate side-to-side so much, that's unlikely to be an issue. So set the bones to y, z, x Euler. So now let's add the control bone. To do that, I'm simply going to duplicate the first finger digit. By duplicating the first digit, we guarantee that it is in exactly the same orientation, which we want. Now we constrain the first digit to the control bone with copy rotation constraints. Now if we rotate the control bone, the first finger digit goes with it. So this takes care of being able to rotate the first digit with the control. Now we need to make it so that scaling the control bends the second two digits. We really only need it to scale on one axis, and it looks nicest if it's the y-axis. So lock the other two axes. Now it only scales on the y-axis. Now, there are actually two ways we can make the finger bend when scaling the control bone. One way is to use drivers, but another way we can do it, and the way that we're going to do it, is with something called action constraints. Action constraints are a slightly strange constraint in Blender. Remember how the animation of objects are stored in actions? Normally those actions affect objects based on the progression of time. But with action constraints, we can have actions affect objects based on the transforms of something. What this means for us is that we can simply make an animation of the finger bending, and then have that animation affect the bones based on the scale of our control instead of based on time. So let's try it out. Make sure you're on frame 1, and set a key on the second two digits in the unbent position. Now change to 10 frames later, on frame 11, and bend the finger, and set keys for that bent position. Now if we scrub the timeline, we can see the finger bend and unbend. Now what we're going to do is take this animation and link it to the scale of the control bone. To do this, we first need to do a little bit of action management. Create a new window and switch it to the dope sheet view. And change it from dope sheet mode to action editor mode. From here we can manage actions as pieces of data. We can see the name of the action on the currently selected object here. Let's rename it to something useful, like finger bend. Also, we want the interpolation to be linear for this. By default, Blender interpolates keyframes with Bezier curves, which creates an ease-in, ease-out kind of effect. But we don't want our controls to automatically do that, because if the animator doesn't want that, they'll have to counter-animate against it. Linear interpolation, on the other hand, will reproduce exactly whatever the animator does. To change the interpolation to linear, make sure all the keys are selected with the A key. They should all be yellow. Then press T, and select linear from the menu that pops up. That sets the interpolation type to linear for all of those keys. Now let's remove the action from the armature, since we don't want it animating with time. We only want it to animate when we scale the control bone. To do that, click the X here. Now if we scrub the timeline, nothing happens. And now it's time to add the constraints. We need to add an action constraint to each bone that we want to be affected. The control is going to be the constraining bone, so select it first, then the second digit bone, and add an action constraint. Go to the bone constraint properties. We need to specify what action is going to be used. In this case, it's finger bend. And we need to select Scale Y as the transform channel that drives this. We're almost done for this bone. We just need to specify the mapping. The action starts on frame 1 and ends on frame 11, so enter those into the action length fields. The min and max fields represent the values of the transform channel that will correspond to the beginning and end of the action. The names are a little misleading because min doesn't actually have to be smaller than max. Just think of min as the value that matches up with the start frame, and max as the value that matches up with the end frame. In this case, we want unscaled to mean unbent. 1.0 is the value for no scaling, so put that in the min field. And let's put 0.5 as the max, so the finger is fully bent when the control is half size. Let's try it out. Scale the control bone. Ho ho, look at it bend. We could repeat this process for the other digit, but it's easier to simply copy the constraint. Select the third digit, and then the second digit. In the Pose menu under Constraints, there's an item called Copy Constraints to Selected. This will copy all the constraints on the last selected bone to all the other selected bones. Click it. Ta-da! Now the third digit has the same constraint. Try scaling the control bone now. Cool. And if we rotate it, the first digit rotates with it. We now have a single comprehensive control to do most of what we want with the finger. How cool is that? Also, one of the benefits of action constraints is that due to the way they work, we are able to animate the constrained bones on top of it without having to do the whole parenting trick. So this way the animator can still tweak the individual digits if needed, which is important, because sometimes the animator may need the finger to do other things. But this single control covers most cases, and makes those cases a lot faster for the animator to manage. Anyway, that's how we can accomplish this with action constraints. However, the real power of action constraints is when you have a very complex action that you want the animator to be able to easily control. For example, the gears of a jet airplane raising and lowering, with lots of complex hydraulics. There's no reason for an animator to have to manually animate that every time. So instead, we could use an action constraint to drive it with a single control. For this finger rig, we could also have accomplished this rig with drivers and the parenting trick for animating on top of automation. But action constraints are a little bit easier and allow us to use fewer bones. As a last step, let's scale our control bone up and move it to the same location as the first finger digit. Now when we use the control, it feels more direct, like we're really grabbing the finger and moving it around.